Hi, this is Math 6, Unit 1, Lesson 16, distinguishing between surface area and volume. This whole lesson here is one that you may or may not do today in class. It's kind of an optional one. Just kind of a couple things we're talking about and putting some ideas together. First of all, when we're talking about surface area, remember we're talking about covering essentially the outside of a three-dimensional shape. And when we're talking about volume, we're talking about kind of filling the inside of a three-dimensional shape. Those are kind of major differences there. We're going to talk about those things. So first of all, we have several quantities down here and some units. What it wants us to do then is to use the units and connect them to one of the quantities here. The units here are different measurements here. We have things like millimeters, which are really, really small. If I have a ruler out here, the millimeters are the itsy bitsy teeny little lines there. Those are millimeters there. We have feet, which would be one of these, one ruler, and meters, which is a meter, right? So those are all some lengths here, right? Some small lengths, larger, and even longer. Square inches is dealing with, again, square inches, what you might use for an area. Square feet would be like an area, but even larger. And of course, a square mile would be even larger than that, right? So these ones here tend to deal with areas. These are just length measurements. And the cubic ones are dealing with volume, right? So it's a cube. So we have cubes here that we're talking about there. So the cubic ones are dealing with volume. We have kilometers and yards. Kilometers are much larger than yards. This is a small one and a large one here. Okay? So we're talking about the perimeter of a parking lot. A parking lot, like so, would be a distance around. We're not talking about the space inside, just the distance. So you might use feet, or you might use meters or something like that. If you're talking about the volume of a semi-truck, right? So you have your truck. This will be a terrible truck, I can already tell. And the way I'm drawing it here, so you have your truck, and you have your semi-truck, and it has this big old box in the back, right? So the volume of what goes inside of that truck, we're talking about, because volume, either cubic kilometers or cubic yards. Well, kilometers are large, or very long. That's like what you measure. They're longer, or actually a little shorter than a mile. So we're talking about a distance there, pretty big distance. So we probably would use cubic yards for what goes inside of a truck, because that's not going to be a kilometer long. It's just not going to happen. The surface area of a refrigerator. Alright, so you have your refrigerator here. There's your nice door, ready to go. And again, refrigerator, surface area is going to be done with square things, so you probably could use square feet, or if you wanted to, you could use square inches. There would just be a lot more of them. Length of an eyelash, alright, so you have your eyeball there, and your eyelash is a distance, so we have a choice between millimeters, feet, and meters. Probably going to go with millimeters there, unless your eyelashes are extremely long and they're a foot long. Those would be some pretty crazy eyelash extensions. Not sure why you'd want that, but I've seen some crazy things these days. And 5, the area of a state. Of course, I am in the charming state of California. Something like that, right? That's a terrible picture of California. Of course, I live in the middle, which is in Fresno right there. But I'm doing the area of a state. I'm talking about the space on the inside. And that's going to be a square something or other. And since the state's pretty big, we would probably go with square miles most likely. The volume of an ocean, the ocean's quite large and quite deep. So because volume, we're doing cubic. And probably you would use cubic kilometers, most likely. Could you use yards? You certainly could, but probably that would be a little better. And there's 2 there for you to kind of decide what you want to do. If you were going to use miles, what could that be? Maybe that's going to be the distance from home to school. You might use miles. And cubic meters, again, that's a volume thing there, but not as much. Meters, maybe you're talking about how much water to fill a pool. So the volume of a swimming pool. It might be cubic meters there. All right, in the second activity, your teacher is going to give you 16 cubes, and we want you to build 2 different shapes using 8 cubes for each shape that you build. All right, that's the idea, using 8 shapes. So to do that, we could use our Unifix cubes once again, right? And I can make a shape that has, there's 5, 6, 7, 8. If I had 8, I could possibly take them and I could stack them up like this and have a 4 by 8, something along those lines. That could work there for one shape. I could even take a couple of the shapes here. I could stick them on top like that, and I could have a, a little shape like this. That's still the same number of cubes and the same volume, but it would definitely have a different surface area. Okay, we could put 8 like that and make an actual giant cube, a 4 by 4, something along those lines. That would work. So there's a variety of ways that you can do that, and you can create shapes there. And so this is for an opportunity for you just to make your own shapes with your 16 cubes, and each shape uses 8 cubes each. And for them, you want to go ahead and figure out what the volume would be and the surface area, and then label them up as best you can. Alright, so do that, and then you can start up with activity 3. Alright, for activity 3, it says comparing prisms without building them. 3 rectangular prisms each have a height of 1 centimeter. Prism A has a base that is 1 centimeter by 11. Prism B has a base that is 2 centimeters by 7. And C is one that's 3 by 5. Alright, so let's take a look at A first of all, which is a 1 by 11. Okay, the tricky part with drawing this out on this dot paper here is that 11 is pretty long, so you don't want to start too high or you run out of space. So I'll go ahead and start right about here with our 1 by 11. Because it's only a height of 1, I don't have to worry about a top on it. But I'm going to go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we'll extend that out all the way to 11 as well. 11 as well. Oops, one more. And we'll get our top. We'll draw lines across, like so. And our lines down to indicate where each cube is going to be. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's A right there. For B, it's going to be a 2 by 7. So I could come here and we could draw 1. We can go 1. I can come out here to 2. Alright, and now I can get my length of 7. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we come out here to a width of 2. And we go down. And there's 2. We'll come across. Come across. Come across. Come across. Come across. Down, 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 and down. So there's B. And then C, if we have some room here, let's hope we do. And we're going to go to have 3. 1, 2, and 3. And it says 3 by 5, so we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we go down, and across, down, 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 and down. And there we are, straight across, like so. Okay, so now we have all 3 of our shapes drawn. They're all 1 centimeter high, and they have their base that is a 1 by 11, a 2 by 1, 2, 3, 4, 5, 6, 7, and a 3 by 5. So the next thing it wants us to do is to then find the surface area and volume for each one. So looking at the first one here, our surface area, we have 11 on each side, right? So 11 showing there, and there are 4 sides of that, so it's 11 times 4, which is 44. And then we have a front and a back, so plus 2 more. Surface area is 46, and these are centimeters, centimeters squared. For B, the surface area for B, we have 7 on our surface area showing there, and then we have a back side for area of 7, times 1. We have it on the back side, so it's 7 on the back side. Up on the top we have a 2 by 7. 2 times 7. And that's going to happen 2 times. So we'll multiply that by 2 actually. And then we have a front that has just 2 plus 2. So we have 7 plus 7 plus 14 plus 14 plus 2 plus 2. So some crazy numbers there, right? So we have 14, 28 and 14 and 4 for a total of 46. And over here we have this 5 by 1. And the back side is also a 5. The front is a 3, the back is a 3. And the top is a 3 by 5, which is 15, and another 15. So surface area is 30, 40, and 6 makes 46. So they all have the same surface area. Kind of interesting, right? They all look different, but they have the same surface area of 46 centimeters squared. But what about the volume? When we talk about volume, we're talking about how many squares or cubes are being used. This one has a volume of 11. There are 11 squares that are used. For B, we have 7 plus 7 is 14. We have 14 squares being used. And for this one, we have 5, 10, 15. We have 15 squares being used. So that's our surface area and our volume for each of those. It's not very dark there, so let me highlight it a little darker. Okay, so the next question on the next page, what it asked us then, we've had the surface area of the volume, this says, analyze the volumes and surface areas of the prisms. What do you notice? Write 1 to 2 observations about them. So a couple observations you might make here. You might notice that the surface areas are all the same. You could notice that C could hold the most of whatever you want to hold in there because it has the greatest volume. A would hold the least because it's the least amount of volume there. But it also could hold the longest items too. So if you had something nice and long, like a long, I don't know, stick, broom handle, baseball bat, I don't know, you could probably put it in there. But if you had some shorter stuff, then you might be able to use the C or the B box. Okay? Anyways, just some activities there again, just playing with surface area and volume a little more. So just to kind of summarize here, all right, what we're talking about. In summary, a length is a one-dimensional attribute. Okay, so like you use a ruler to measure with. An area is two-dimensional. It's like what you'd have like in a window, right, or door. But volume is a three-dimensional attribute. So having a filing cabinet, a refrigerator, something along those lines. And so you use different measurements to use on a length and an area and a volume. Okay, so these are going to all be things like meters, kilometers, inches, feet. Area is going to have a square centimeter, and then a volume is going to be cubic. Okay, so keep those things in mind. And then the last part of summary is that just saying that surface area and volume are different attributes of a three-dimensional figure. So when you're working with a three-dimensional figure, you could be talking about surface area or you could talk about volume, and both of those are fine to talk about. All right, we're going to pause there. Let's give a moment to do your homework, and we'll come back and check it out in a minute. Okay, for our homework for lesson 16, Math 6, Unit 1, match each quantity with an appropriate unit of measurement. Surface area of a tissue box. So with area, we're talking about something that is going to be a squared measurement. So my choices, I have square meters and square centimeters. A meter is quite large, so I'm going to go with square centimeters because that makes more sense for a tissue box. The amount of soil in a planter box. So you're filling that up, right? If you have soil in a box, you're filling something. That's dealing with volume. So I can look at a planter box being a volume of inches or feet. Usually when you're planting something, you need more than some inches, so let's go with the cubic feet. Area of a parking lot, again, area is something that's square, and I'm going to go with square meters. Length of a soccer field, it's just the distance, and I have yards, that makes the most sense of what's left. And then finally, for volume, I have a fish tank. I can use cubic inches right there. Alright, so that's what we have. Number 2, here's a figure built from snap cubes. Find the volume of the figure. Volume is going to be how many cubes there are. 1, 2, 3, 4. That's exciting. So 4 cubic units. Surface area. Well, surface area is going to be this length of 4. And I have it on one side, 2 sides, 3 sides, 4 sides. So 4 times 4 is 16. Then I need to add the top and the bottom for a total of 18 square units. And that is going to be our surface area. True or false? If we double the number of cubes being stacked, both the volume and surface area will double. Explain how you know what you know. So if we take this lovely shape, and instead of having 4, we have 8. 1, 2, 3, 4, 5, 6, 7. 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have it doubled. I know it's not double in actuality, but if we double that up, will the volume be doubled and the surface area doubled? Well, the volume, we had 4 before. Now we have how many the squares are. That's 8, so that looks good. But for the surface area, I now have 8 right here times 4 sides. 1, 2, 3, 4. 8 times 4 is 32, plus a top and the bottom, which is 34. That's larger, but is it double? Well, originally we had 18. 18 times 2 is 36, so this is actually not doubled. That's our problem right there. So this would be a false statement because the volume is doubled, but the surface area does not become doubled when we do that. Number 3, Lynn said that 2 figures with the same volume, also the same surface area. So when I look at these shapes here, she says there are 2 figures that have the same volume and the surface area, that there are 2 of them that have the same volume and surface area. So which 2 figures suggest that her statement is true? Well, let's take a look first of all at the volume of each of these shapes. We'll find the volume of each one and see which ones have the same volume. This has a volume, we count this cubes, 3 and 3 makes 6. Here we're going to assume there's one behind there, so we have 1, 2, 3, 4, 5, and 1 hidden behind there we're going to guess for 6. Here we have 3, 4, 5, 6. Here we have, again, probably 1 hidden behind there, so 6 plus 1 more is 7. And 1, 2, 3, 4, 5. So already we can eliminate E and D. I don't have to worry about surface area there. Not going to work. For surface area, let's take a look at surface area for the ones that are left. Surface area. For this top one we have 3, 4, 5, 6 blue, and on the back side, double it up, it becomes 12. So blue is 12 plus yellow, 1, 2, 3, 4, and the back side makes 8. And then the green we have 1, 2, 3, and the back side makes 6. So surface area here is 12 plus 8 is 20, plus 6 is 26. For this surface area we have again blue plus yellow plus green. Blue is 1, 2, 3, 4, and double that becomes 8. Yellow is 1, 2, 3, 4, 5, and then we double that, which becomes 10. And green becomes 1, 2, 3, double that becomes 6, for a surface area of 26. Am I doing that right there? No, something's not quite right. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 10, 1, 2, 3, 4 is 8, and 24. I'm sorry. Just can't add to date. It's a little late. So 24. So 26 there, 24. So far those don't match. Let's look over here. We have blue is 1, 2, 3, and double up becomes 6, plus yellow 1, 2, 3, 4, 5, 6, double up becomes 12, plus green 1, 2, 3, double up becomes 6, and that becomes a whole 24. So which ones have the same surface area and volume? That becomes B and C, because their surface area is both 24, their volume is both 6, so it works great. B, which two figures could show that her statement is not true? Well, we could say that A and B are not show that's not true. That's because the volume's the same, but surface areas are different. Same could be said of A and C. Volume's the same, and surface areas are different. So there's actually two choices there. So, is she right? Yeah, there is something that shows that she is right, but there are also two things that show that she's not always going to be right, so she should be careful. Number 4 is a tricky little question here. It says, draw a pentagon, 5-sided polygon, that has an area of 32 square units, and label the relevant sides. So, what I decided to do here was think about two shapes combined together. If I took a square, right, and I took a triangle, okay, can I break that apart and figure out a way to do this and then combine them back together? Because I'm doing an area, I can combine them up. When I first started thinking about it, I thought, well, if I did 5 and 5, that becomes 25, and now I have a 7 left to figure out. Can I do it with 7? Probably, but knowing that the area of a triangle is 1/2 times the base times the height, I don't know if it's easy to get numbers here that are going to come and equal 7, an odd number. That's a little tricky. So I decided let's not use 5. I thought let's use 4 instead. Again, I didn't do 6 because 6 times 6 is 36, I'm too big. So 4 times 4 is 16. So now I need to get the area of a triangle to be 16 as well. So if I was to take this triangle and slide it on top of that one, for example, I could have a base of 4. So if I made a base of 4 and I don't have a height yet, but I know my area needs to be 16, can I figure out what a height could be? Sure. So half of 4 is 2. So 2 times the height is 16. We divide both sides by 2. And if I use a height of 8, like this, I have something that works. So if I combine those together, I can make a square. That's a 4 by 4. And then I can make a triangle out here, right, that has a height of 8. And that works out just fine. Okay, so something like that could work. Number 5, sorry. Draw a net for this rectangular prism and find the surface area as well. Alright, so what do we have? We have the long side of 10. So I'm going to go ahead and draw the long side of 10 first of all. And I have lengths of 5, 2, 5, and 2. So I can come across here and make a 5. Then I can make a 2. Then I make another 5. And then make another 2. That becomes what goes around the shape right here. The 10 by 5 and 10 by 2 and so on. Now I need to put the caps on them. So if I have a cap here of 2, my base, then I need to have the other side of a 5. So this becomes a 5 and a 5, a 2, a 5, a 10. And I do another one over here for a 5 and a 2, 2 and a 5. These are all lengths of 10. That's a 5 and a 2, a 5 and a 2 and a 5. So that's about what that net would look like. For the surface area, I have 5 times 10 is 50. 2 times 10 is 20. Then I have a 50 here and another 20 there. And 5 times 2 is 10, and 5 times 2 is 10. So 50 plus 50 is 100. 100 plus 20, 120, 140, 150, and 160. So our surface area would be 160 centimeters squared. And that's it for that one. Okay, that's it for today. Have a great day, and we'll see you next time.